So we are looking at different types of series. In the previous video, two videos, we discussed geometric series. So the next one we are going to look at is called collapsing series, or sometimes in some books they call it telescoping series. So actually in our book, the name telescoping series has been used. And we start by looking at this this example below. So we have summation, something like this, and when we expand it by plugging in the values of n, we end up getting terms of this form. Notice here, this is not a geometric series because we do not have a common ratio. If you try to find the ratio of the first two terms, so take the second term, which is 1 over 3 times 4, and divide it by the first term. So you will end up seeing that you get 1 over 3 times 2. So you get 2 over 4, or 1/2. Now you take the third term, so 4.5, and divide it by the second term. So you end up getting 3 times 4, and then you notice that you get 3/5, which is not the same. So the ratio is not the same, so this is not a geometric series. So how do we find whether this kind of series converges or diverges? So there is actually, it is easily computable, and what we do, we follow these steps. So the first step is that we write this expression here in as a partial sum. So if you recall, we can write this thing, find the partial sum of this by writing this as a over n plus 1 plus b over n plus 2. So which gives us 1 is equal to a times n plus 2 plus b times n plus 1. Set n equals -1. So this gives me 1 equals a into 1, or a is equal to 1. Now set n equals to -2. This will give me 1 equals b into -1, or b equals -1. So that our series can be written as summation n is equal to 1 to infinity 1 over n plus 1 minus 1 over n plus 2. So once we get this, this is what the series is. So what is the partial sum? Now we are going to look at the partial sum. So again, the partial sum can be called s sub k or s sub n or whatever, because already we are using the n inside here, so we shouldn't be using it in this partial sum. So we are now going to call the partial sum as sub k. What that means is that n is going from 1 to k, so that this is our series, and now we expand it now. So instead of expanding it like we had it in the beginning, we expand it now. So when we expand it in here, we end up getting this. Actually, we will be using each value of n. So when n is 1, we have 1 over 2 minus 1 over 3. Okay, so this is when n is 1, plus, now when n is 2, we get 1 over 3 plus 1 over 4, and so on. So notice here I am keeping these each term in parentheses just to see the difference, so to see that we didn't forget anything. Plus dot 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 plus, let's look at k minus 1. So when n is k minus 1, so 1 before the last term. So when n is k minus 1, so notice here you will get 1 over k minus 1 plus 1, or just k, minus k minus 1 plus 2 or 1 over k plus 1. And now the last term, so which will give me 1 over k plus 1 minus 1 over k plus 2. So notice here, when we write it like this, we notice that some terms get cancelled. So this cancels with that. In the same way, 1 over k plus 1 and 1 over k plus 1 cancel from here. And actually what is going to happen, it's all the terms in between are going to get cancelled. So this 1 over 4 will be cancelled with the next 1 over 4 we will get. And because this is 1 over 3 minus 1 over 4, so the next term, remember, will be 1 over 4 minus 1 over 5. So now negative 1 over 5 will be cancelled with the next term, and so on, so on. And this 1 over k will be cancelled by the previous term. So the only two terms that are left are the first term and the last term here. So we now write that this is equal to, so sk equals 1 over 2 minus 1 over k plus 2. So now once we got our sum in simplified form, now we will find the limit of this sum. So the limit as k goes to infinity of s sub k will be equal to limit as k goes to infinity of this quantity 1/2 minus 1 over k plus 2. And we know that the 1/2 will stay as it is, but this quantity, the second one here, will go to 0, so that we end up getting 1/2 as our answer. So this is actually the value of the series. So in other words, we say that this series n is equal to 1 to infinity 1 over n plus 1 times n plus 2 actually is approaching 1/2. So this is called collapsing or telescoping series, because you see all the terms in between collapse, they go away. Okay, the next type of series, actually, so we can have different types of these telescoping series which have different expression in them, but the next one which we are talking about is the harmonic series, and this is just one of its kind. So anything which is something like this, but you can start anywhere. But notice here you cannot start at 0 because you cannot have a 0 in the denominator. So how do we figure out whether this series converges or diverges? So in order to do that, we take the idea which we just saw. We will find the partial sums, and then we will try to see what is happening with these partial sums. Where does the limit go? So remember, the partial sum s sub k will be equal to summation n is equal to 1 to k of 1 over n. So it will be 1 plus 1/2 plus 1/3 plus 1/4 plus dot dot dot, plus the last term will be 1 over k, and the term before that will be 1 over k minus 1. So this is the s sub k. Now again, by looking at this sum, and if you know what this if you dealt with these type of things, and if you know what is the formula for that, you may use that and then take the limit. But at this moment, let's assume we don't know the formula. So what we are going to do is, because we need to find the limit, so we are going to see by taking small sums and trying to see what is happening. So we notice that s sub 1 is just 1, s sub 2 is 1 plus 1/2, which is 3 over 2, but it is a number which is greater than 1, right? Okay, s sub 3 will be 1 plus 1/2 plus 1/3. Okay, we don't have to write each and every, so let's skip some. First we write s sub 4, so which will be 1 plus 1/2 plus 1/3 plus 1/4. And so you will notice that this is giving us well, again we kind of use a trick here. So we notice that this number is going to be bigger than 1 plus 1/2 plus 1/2. Okay, and why are we doing that? Well, the first two are the same, right? 1 and 1/2. But in place of this one, which is actually going to be 7 over 12. So 7 over 12, remember, is more than 1/2, because 1/2 is 6 over 12. So this whole thing is replaced by 1/2. Now this quantity is 2. Now if we look at S8, for example, so what will that be? So this is going to be 1 plus 1/2 plus 1/3 plus 1/4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. So we kind of do the same trick here. So combining these two and these two and these two. So notice here, this is actually, if we combine these two, this is giving me, as before, 7 over 12. And this will give me 11 over 30. So which is not 1 over not bigger than 1 over 2. So what we do now, we actually combine all these four terms. So which is going to be a number which is much bigger than 1/2. So and what is this number? Well, again, we are not worried about what that number is, but we do know that this sum is going to be greater than 1/2, and you guys should be able to check that. So what I am going to do now, instead, I am going to say I am instead going to do something else here. I'm going to say that this number or this sum will give me something which is bigger than 1 plus 1/2 plus 1/2 plus 1/2. Okay, so this is bigger than, and if you notice, this one is coming out to be 5/2. Okay, now in the same way, jump to another value. So for example, if we take S16, so if we take S sub 16, so the partial sum of the 16 terms, then we will be getting, so let's look at this one, S sub 16. So you should be able to see that that will give us 1 plus 1/2 plus 1/3 plus dot 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 plus 1 over 16. And like before, we will take the first term and the second term and the third and the fourth term combined, plus, now as before, we will combine the next four terms. So we have 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8, and now plus the rest of the terms we will combine again. And you will notice that this thing is greater than actually 1 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So this is what we are doing, replacing this by 1/2 replacing that by 1/2 and replacing this sum by 1/2. But because in each case they are not equal, so the sums of these terms of the sequence are less than actually 1/2. And so, which if you look at this one, this is going to give you 3. So we are getting a number greater than 3. So every time we combine more terms, we are getting larger and larger numbers. So this kind of gives us an idea that limit of s sub k as k goes to infinity is going towards infinity. So the series diverges. So now you should know that a harmonic series diverges. So this is something you have to remember. Harmonic series diverges. So note here, harmonic sequence will be 1, 1/2, 1/3, 1/4, dot dot dot. General term will be 1/n. And notice that limit of 1/n as n goes to infinity is 0. So harmonic sequence converges, but harmonic series diverges. This is what you need to remember. Sometimes when we are checking the convergence or divergence of a series, it's easier to check if the series diverges. So if the series diverges, we don't have to check the convergence of the series or find out if it is converging, because if it is diverging, it cannot be converging. And the divergence test says that if you have that the nth term has a limit which is not equal to 0, or if this limit of the nth term does not exist, then the series is sigma a sub n will diverge. Okay, so if the limit a of the nth term is not equal to 0, so if the limit of the nth term is equal to a number, or the limit does not exist, then the series will diverge. So notice here we are not saying anything about convergence, but we now know when will a series diverge. The second part is sometimes it would happen like in the case of the harmonic series, the limit of the nth term comes out to be 0. So then what? Then we say that this test is inconclusive. Then we cannot say whether the series converges or diverges. It will depend on some other things, and we will have to use some other kind of test. So how do we check whether a series diverges or converges? Well, again, look at this first example. If you can notice that this is actually a geometric series, so this is a geometric series because we can write it as 3/2 plus 3/2 to the n plus to the 2 plus 3/2 to the third plus dot dot dot. So you can notice that a is 3/2 and r is also 3/2. But 3/2 is a number which is bigger than 1. So which means the absolute value of r is bigger than 1. So series diverges. And what is the reason? You should write here geometric series. So always remember, when we are going to write whether a series diverges or converges, we must state the name of the test. So we kind of use the geometric series. But you can also use the divergence test here. So in order to use the divergence test, you will say an is 3/2 raised to the power n, and limit of a sub n as n goes to infinity will be equal to limit 3/2 raised to the power n as n goes to infinity. And since 3/2 is bigger than 1, this thing will be infinity. Okay, and you can say because 3/2 is bigger than 1. So therefore, divergence test tells us that it diverges. So by divergence test, the series diverges. So looking at the next one, so our an is 1 over n squared, and if I take the limit of this one, n goes to infinity, then the limit is going to be 0. So by divergence test, so you must state the name of the test. We cannot say anything, so we say inconclusive. So we don't know yet whether the series converges or diverges. So this is how we will be using the divergence test. Okay, let's look at one more example here. So if you have summation n over n plus 1, n is going from 1 to infinity, then notice here that an is n over n plus 1, and since the limit of a sub n as n goes to infinity is the limit of n over n plus 1 as n goes to infinity, and we know that this limit is going to be 1 because we can write it as this dividing top and bottom by n, and this gives us 1 over 1 plus 0 or 1. So since we got a number which is greater than 0, so by divergence test, diverges. So that's what the divergence test said, that if the limit is not equal to 0, which means it is equal to a number, then the series will diverge.